Okay, so this is the plan and sectional plan and elevation of shell type. Plan and elevation of shell type transformer. Which I had done. Now I will do how to do this. I will show you how to do this. Plan and elevation of shell type. So we have learned in the machines what is shell type transformer, what is core type transformer, and also you can go through the video that I've shared on Microsoft Teams, just the difference between the shell type and core type. So here you can see this is the winding part and this is the central limb. So central limb. So the windings will be in the shell type, the winding will be wound on the central limb. So that's what it is, and this is the elevation part. And this we call, and this is the plan, and this is the elevation. This we call it as plan, and this we call it as elevation of assembly diagram. Okay, so we will see how to do this. We have also shown the dimensions here. So you can see 14 is the width of central limb. So this is the width of the core, 54. So we will see how exactly to do it, and at the end we have to show the dimensions of all these. So we'll see the question first. So this is what we have to develop now. We will do it again, taking the AutoCAD software. So I'll show the question first. Okay, so this one, draw the sectional elevation and plan of the single phase shell type transformer for the following data. The rating of the transformer is given as 125 kVA single phase. So width of the central limb, it is 14 centimeter. Overall height of the core, 38. Overall width of the core is 54 centimeter. Overall depth of the core. So core has got height, width and depth. And window dimension is given 13 by 24, that is length into height. Window width into window height, that is 13 into 24. And also winding, regarding the winding they have given there are total 4 coils of ELV winding and 4 coils of HV winding. So placed alternatively. I'll just show that how it will be. Here you can see I have done different hatching for LV and HV. So this the first one is the LV winding and then HV winding, again LV and HV. So these two windings are separated by some insulation, that is solid insulation I have given here. Solid hatching is given, so that is insulation between all the windings. So you can see there are total 4 HV windings and 4 LV windings. So the same thing is mirrored here this side. We will see the question completely first. So regarding the winding, they have given 4 HV coils, 4 LV coils placed alternatively. Rectangular coil dimension. So rectangular coil dimension is given. So this means the windings we have placed. Above that it's a rectangular coil. So that is 15 by 41. Outside outside dimension is 35. This is inside dimension, and outside dimension is 35 by 57. And thickness of the coils. So HV coil is thickness is 2 centimeter and LV coil thickness is also 2 centimeter. But in between that we have to provide the insulation. Insulation support between the coils is 1 centimeter. So between HV and LV we have to place this insulation of 1 centimeter. and the coil thickness is 2 centimeter. You can see here these coils, these are all the same hatching. You can see the pattern here. So all these are LV coils which are of 2 centimeter thickness. After that 1 centimeter insulation, again 2 centimeter thickness of HV coil. Like this we have arranged them. LV and HV coils are arranged, and this is the plan, and then we have to extend these lines to get this elevation. So we will be doing the same thing on AutoCAD software. I'll just close this and I'll again open the okay, so we have opened the AutoCAD software. Now what you have to do, first thing is you have to do some initial settings to set this workspace for A4 size, because you'll have to take the printout of this, no? So you have to set it for A4. For that, the same thing should be followed for all the drawings. So first thing is units, UNITS. Set this to millimeters. So this is already 2 millimeters. I will not change this. Okay, and then type limits. Limits you have to set. Then first specify lower left corner 0, 0. Enter 297, 210. Enter. Sorry, it was 287. I will type limits again. Limits 0, 0. Enter 297, 210. So this is common for, this is same for all the problems, all the diagrams. Enter, and then the command zoom. Enter all. So here they have said all, center, dynamic, extends, previous, scale, window, object. So in this you have to select all. You want to zoom everything. So all, enter. So this is the initial setting. One is units, limits, and then zoom. These 3 commands have to be given, and then this is ready for the drawing. So first what we have to do is, with all the data that is given in the question, you have to start drawing the plan and elevation of a shell type transformer of 125 kVA single phase. So for that, what we need to do is, first we have to draw a horizontal line. Keep this ortho on so that we get the straight lines. So draw an horizontal line and a vertical line. Okay, so now we have to create the elevation part. For that, the dimensions are given like, so when you want some line from this horizontal line from of 7 centimeter or 7 mm distance, if you have to draw a line from this which is 7 centimeter away, then we can go for the option. You can just type here offset, enter, and you have to provide how much offset distance you want. For this we want the offset distance, because first in the question what they have given, width of the central limb. I've also shared that PDF with you in the Microsoft Teams, so you can just download it and refer for the question. Width of the central limb is given 14 centimeter. So we have to divide it by 2. It's 7. So provide here 7, because we are giving offset on either side of the line. So you have to divide it by 2. So now I have given, specify the offset distance as 7. Enter. Then you have to select. So this is, as its width, we have to take it on either side of this. So select this vertical line, press here. So this distance between these two is 7. It's 14, sorry, not 7. Between this and this is 7, and between this to this is 7. So total, the width of central limb. Now we are showing the width of central limb is 14 centimeter. Okay, so now the next thing what we have to do is the height of the core we have to show. So how we do the height of the core is, now again type offset, 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 enter. Now we have to provide the height of the core is 38 centimeter, divide it by 2, it will be 19. So give 19, enter. Now this has to be done with respect to horizontal line, because height we will show like this. So on this side, select this, press. So this is the total height of the core is 38 centimeter. From here to here it is 38. So from this line to this line it is 19, and from this to this it is 19. Now after this, once we are done with the central limb width and height of the core, we have to go for overall width of the core. So overall width of the core is given 54 centimeter. So overall width of the core is 54. Again type offset. So all the widths have to be taken on horizontal basis like this, and height will be vertically. So now width of the core is 54. Offset 54 divided by 2 is 54 divided by 2 is 27. So type 27, enter. Now this has to be taken with respect to this vertical line here, the one which you have taken originally. So with respect to this it should be taken. So select this, press on this side, select this, press on the left side. Now we got this as the overall width of the core. This is the width of the core, which is 54 centimeter from this point to this point. You can see this dimension linear. So it is 3.92. It has to be 50. Yeah, it's 54 only. So after this, the next step is again one more dimension is given, that is overall depth of the core. Depth of the core is 37 centimeter. So now this is the elevation part. So select all of this and trim the extra parts. So here the trim option is there. Take this, select this, trim this part and trim this part, because we are going for the core, we are drawing the core part here. We will not trim this part because we have to have the extension lines here. Now window dimension is given. Window dimension is 13 into 24 centimeter. So width is 13 and height is 24 centimeter. Width you don't have to divide it by 3, so we will take 13 itself. So offset, give here 13, enter. Then this has to be with respect to this and this. Now again height of the window is given 24 centimeter. So 24 we have to divide it, again give offset, enter. 24 divided by 2 is 12. So give 12, enter. Now this has to be with respect to the center line, horizontal line. Press on this side, select, press on above and below. Now you can see the core is ready. So we'll have to just trim the extra parts. So we can just trim the extra parts. So whenever you want to trim, then you have to do Control A. That means it will get selected. Everything will be selected. Now you can just go for this option on the right side, trim, and you can trim all this. You can just delete the other lines. This you can also delete this line. You can trim it. Select all. Okay, so we need to have this. This is one coil and this is another, and on this we will be having the HV and LV coils. Now what we have to do is we have to draw a horizontal line like this. You can draw anywhere the horizontal line. Now overall depth is given as 37. Okay, so depth we have to show in the here. So for that, type offset. So the overall depth is given as, overall depth of the core is 37 centimeter. So 37 divided by 2, it will be, whenever you are using offset, why we are dividing, because we are giving on this side also, on this side also. So we have to divide every time by 2. So the offset distance we have to give here is 18.5, because 37 by 2 is 18.5. 18.5. Enter. Now take this as the reference line, press above and again select this, press below. So this total width, this will show the width of overall depth of the core will be shown by this part. So this much is 37. Okay. Now after this, what we have to do is we have to form this window dimensions here. Window should be formed. So for that, the window dimensions are given as 13 is the width and 24 is the height. So select a rectangle option from this toolbar. Rectangle is selected. Start, press somewhere, and this should be drawn separately, so that we will take this afterwards. So select the rectangle, specify some point and don't stop it here. We have to give the dimension for this rectangle. For that you have to type D first. D, enter. Now you have to give the dimensions of it. That is 13 by 24. So okay, the rectangular coil dimensions are given as, inside dimension is 15 by 41. So we have to give 15 by 41. 15, enter, 41, enter. So we got the rectangle here. Just this is This is the coil inside dimension. Rectangular coil inside dimension is 15 by 41. That means 15 is the width and 41 is the height of the rectangular coil. Now take one more rectangle and again start, just specify the starting point and give D, enter 35 by 57 because it is outside rectangular coil. So give 35, enter 57, enter. So now I got this also. What we have to do is we have to just draw the diagonals for this. So just join the adjacent opposite vertices. Same thing for this. Okay. So these two are the rectangular coil dimensions. This coil is inner coil 15 by 41 and this is the outside coil, that is 35 by 57. So now we have to place these two with center at this point. So what we have to do is select this complete, right click and choose the option copy with the base point. You also have the option copy, but if you just copy it, what happens, we will not be able to place it exactly where we want. So go for copy with the base point. So I'll click on this. So now it is copied with the base point. Now we have to paste it. So Control V. It's getting loaded. Sorry. Nice. So with this as the center, you can place it here. This also you have to select. So it is not getting placed correctly. So copy this, copy with the base point. You can just place it here. So what we have to do is we have to first copy this and then you have to copy this then press right click, copy with the base point. You have to specify the base point here, whether you want the base point to be this or this. I'll select it as center, the intersection point, and then you have to press Control V. So it will be selected, choosing the midpoint, so that you can just go and place it easily. The same thing you can do for the bigger rectangle also. I'll just delete it.
Hello. Hello.
Am I audible now? I think the
Yes.
internet, yeah, internet was not good here. Fine, I'll continue. Okay, so these two are the inside coil and the outside coils with the dimensions of 15 by 41 for this inside coil, and 35 by 57 is the outside coil dimension. So these two we have placed here, taking this line as the center. So now what we have to do is we have to just trim the extra parts here. So whenever you want to trim, go for select all, Control A, then select this option and trim these extra lines. Is the screen visible to you? I have not shared the screen.
No, ma'am.
Then you should say no. As I joined again, I forgot to share the screen because earlier I had done it. So I just continued, and you should say that.
Ma'am, my network is too slow, so I thought it is still loading.
Okay. Anyways, otherwise I would be doing without sharing the screen. Okay, now here we have to, is it visible, Manjunath?
Yes, ma'am, it's visible.
Okay. So now select all and trim all the extra. So we'll trim this also. You can delete that. So what all you can trim is all the inside lines here. Delete this cross lines also. We can delete the inside lines also. And this. We can even delete these lines here. I have to trim this. Okay, so and these can be deleted. Now what we have to do is we have to take the extension lines from this point. From this, keep the ortho on and extend this line up to this point. I'll trim the extra part later. So from this point, extend up to, just trim this. Now what we have to do is we have to provide this HV and LV coils here. So first thing is we have to provide the insulation which is of 1 centimeter. So we have to give offset and then half. So I'll type offset 0.5 because on both the sides we are giving, so 0.5, enter. Now which from here, press here, select this. So this is the insulation. Then we have to give LV winding of 2 centimeter thickness. So what we have to do again, give offset, enter, give 2 as the dimension, enter. So select this line, press here, select this line, press here. After this again insulation we have to give. So insulation of 1 centimeter. Give offset, 1, enter, from here 1, from here 1. Again, offset, again the winding, HV winding will be of 2 centimeter. Offset, 2, enter, select this line, press here, select this line, press here. This you have to continue till all the 4 coils are placed, 4 HV and 4 LV. First LV winding, insulation, HV winding, insulation, again LV winding. So LV and HV have to be placed alternatively with the insulation in between. So now we have to provide the insulation. So offset, 1, enter, give the insulation here and here, again escape, offset, enter, give 2, enter, select the object, select this, in insulation, select this, enter, 2, enter, select this, press here, select this, press here. So now you can just see all the windings, LV and HV coils are placed. First here it is 0.5 insulation, because you can imagine this as a circular one. So here also I am providing 0.5 insulation. After this we have 1 centimeter of insulation between the LV and HV winding. So what we have to do after this is we can differentiate this HV and LV by hatching with different patterns. So select this hatching option, go for ANSI 31, and you can provide the scale here. So the lines have to be very near to each other. So I'll provide the scaling of 0.5 or 0.25, it depends on you. I'll give 0.25. And
12-15 class
at that time 12-10 game ಮುಗಿತದ Okay, so I'll give the hatching here and then here and here. So enter. Okay, so this is the LV winding, LV coils, and we have to provide this HV with a different pattern so that we can have the difference between the both. Now I'll select another pattern like this. The same scaling I'll put at the pick points. So where you want it to be, you just select all those, enter, then OK. So now you can see LV, HV are placed alternatively, and the insulation is also there. So we have to provide the insulation, all this insulation with other pattern, that is solid hatching. So you can just go here, other predefined patterns are there. So in that you have solid, so select the solid, OK, at the pick points. So wherever you want solid hatching, you can just give this. So So all these insulation have to be solid hatching. So enter. Okay, so you can see insulation, LV winding, again insulation, HV winding, like this. So you can just trim this part. I don't need this. These lines, these lines have to be deleted. Okay. So now what we can do is, we don't have to draw this, follow the same procedure to draw here. You can just mirror this using a mirror option here. So what we have to do is, we have to go for select mirror and then select all this, and you should know this midpoint here, and so for that so what is the midpoint of these two, we can see. I'm just drawing temporarily. I'll delete that later. So go for mirror, select this complete, and yeah, so we got the mirror of the same thing. So what is left now is only you have to hatch this part. We can just delete this line. This is not required. Yeah. What we have to do is, we have to provide different hatching patterns here. Here, this is the core part and this is the core part, and the limb you can hatch it with different pattern, and again insulation solid hatching should be provided. So if you do this hatching, and lastly you have to do the dimensions. You have to select linear dimension and give the dimensions everywhere, like this. So that will be the end of this drawing, that is plan and elevation of a transformer. As it's time now, I'll stop. We can continue the next part in the next class. Okay, so what is this? Is it clear? When you practice more, you'll be able to do it fast, and you'll be able to understand the question also. Are you practicing? Manjunath? Okay, fine. I will end the class. Join for the next class.